thank you everybody for having such of interest in the Larose Forest and our wonderful fungi. This afternoon, we'll be talking about the influence of the forest, of the fungi in the forest and the forest management decisions that comes along with that. I'll be covering most the individual tree decision that's being made while we are tree marking, because Steve and I are both instructors on the tree marking committee. And
please
here
press
we
1.
have a picture
Otherwise,
of both
both
of us.
on the line.
Oh, can you hear that? Is something happening?
We're okay here.
Okay. So here we have a picture of the two of us, since we're not on video right now. We don't want the presentation to be too laggy, so we try our best. And here we are. So the picture of on the right side is Steve while we are delivering the tree marking course. So as an instructor, we are called every fall to do presentation, and both of us are there for more than 4 days, helping out students to learn all about the well, everything you have to know as a tree marker. So I'll pass the presentation to Steve. He might want to introduce himself.
Well, then you hit the nail on the head. I am a forester with the United Counties of Prescott and Russell, and previous to that, I was a forestry specialist with South Nation Conservation. I'm still on the forestry committee with South Nation. I'm also co-chair of the certification working group, which relates to forest certification on community forests and private lands in Eastern Ontario. So aside from that, we'll just dig right in. Just to give you a bit of an overview of what we do at Larose Forest. Basically, the goal of our forest management is to balance the social, cultural, economic, and environmental benefits that the forest provides. And there's a whole host of things that feed into how we make decisions to maintain that balance, starting with the needs of the public, the desires of the public, how they feel like we should be managing the forest, the heritage and traditions related to the region, both pre and post settlement. There's a goal to have a sustainable harvest of forest products. We have goals related to ecological restoration. We try to maintain water quality and quantity, wildlife habitat, and a whole host of other things. And all these things basically feed into the overall goal, which is to maintain a healthy, vigorous, and diverse forest. So hopefully the presentation is tracking smoothly here, but I'll keep going and assume that it is, unless Lynn tells me otherwise. So basically, the overall composition of our forest at this point in time, about a third of our land base is conifer plantations, and about a third is wetlands, both treed and non-treed wetlands. And then the remainder is second growth hardwoods. The history of Larose Forest is basically after settlement and land was allocated, most of the forest was cleared for agriculture or for development. And when they realized the properties that Larose Forest is on now, the properties weren't well suited for agriculture. So for a variety of reasons, the United Counties of Prescott and Russell ended up reacquiring properties. And right now we're sitting at about just over 11,000 hectares or 27,000 acres of forested lands. So our overall goal, like I said, is to maintain a healthy, vigorous, diverse forest. So how do we do that? We try to use the harvest of forest products, and we try to emulate natural disturbance patterns and frequency. So for example, the majority of the natural disturbances that are common in this region are frequent small scale type of natural disturbances that would kill a single tree or small groups of trees. And you can see that, can you see my mouse on the screen?
Yeah, we can. That looks great.
Okay, perfect. So where I'm circling here is sort of an example of a small group of trees that would have died out. And then these other areas here kind of represent individual tree death over time. So that's the bulk of what we try to emulate, is that kind of a natural disturbance, where the type of thing that's happening frequently, and it's sort of a lower, not low impact, but it's kind of like it's smaller scale type disturbances. In the middle, you have things like low intensity ground fires. Wind throw is another example of sort of a moderate intensity natural disturbance. These are less frequent than the single tree and small group, but more frequent than the picture on the right, which is the aftermath of a tornado in Ottawa in 2018. So those large scale disturbances, they do happen in our region, but they tend to be fairly uncommon. So that's not something that we try to emulate a whole lot. So the bulk of our forest operations and the design of those forest operations is to emulate those frequent small scale type disturbances on the landscape. So similar to the fact that there's a whole pile of things that factor into the balance and the sustainability that I was referring to also, there are a whole host of factors that influence what we can do on Larose Forest. The long-term targets that I referred to earlier are some of them. The site conditions and their limitations are some of them. We might want to be able to grow hundreds of acres of very large black walnut trees, but our site conditions and the limitations of those sites are going to prevent us from doing that. The tree species that we currently have on the landscape, and then where we would like to be in the future, that's another factor that plays into the decisions that we make. The age of the certain areas in the forest, that has an impact on the decisions we make at any given time. Health and vigor is another big one. We need to be continually monitoring the health and vigor of the different areas in the forest so that we can prioritize our actions. And natural heritage features like wildlife habitat, water quality, raptor nests, like all these things factor into the decisions we make for a particular site. So where do the fungi fit in? You guys probably know as much or more about all this stuff as I do, but I'll throw my hat in the ring anyways. So there's a whole host of fungi in the forest, and the vast majority of them are beneficial to forests. You look at the mycorrhizal fungi and the saprophytic fungi, there would be, like, trees wouldn't grow without the interrelationships they have with mycorrhizal fungi. It's a mutually beneficial relationship that allows both of them to exist in the forest. So we definitely need those guys in there. And the saprophytic fungus are those that decompose wood and other organic matter. So there'd be quite a pile of stuff out there if we didn't have these guys on the landscape. And then the fungi that we're going to focus on today are the parasitic fungi, and those are the ones that are going to be affecting tree quality and often causing mortality. So we've got chicken of the woods here on the right as an example. This is one of the common tree killing fungi that's out in the forest, and Manon's going to talk a little bit more about the monitoring and making decisions based on individual trees and some of the fungi that we look for that will affect that. My computer just went black. Hang on a second here. Okay, we're back, I think. Are we good?
Looks
Yep, we
fine
can
here.
still see you.
Okay, good, because my screens went black there for a second. I'll get it, I don't know, because you're up. So yeah, like I was mentioning, that one of the things that we do is we use forest fungi to determine the health and vigor of individual trees. So relating back to just emulating natural disturbance patterns and frequency, looking at individual tree death and then small groups of trees. So that's one of the things that we're looking at here. And I'm going to pass it over to Manon, and then she'll give you some more detail on that.
Okay, so no questions for now? Everybody's good? Okay. Like I said, Steve and I are tree markers, and every year we tree mark about 100 hectares roughly, and going through the actual forest and assessing every single tree to see if it's a tree to leave or a tree to mark. A tree to leave would be something you would do if you didn't find any defects on it. And assessing for defects, well, you have a whole list, especially in the hardwoods, and a whole list of fungi that you might encounter while tree marking. I won't name them all, but I'll be concentrating on at least the beech bark disease that's really common. And we'll be talking about Netria and Utapella cankers that are easy to identify also. Through that whole list, the actual, the fruiting body that you see on the tree will give you a good idea. It's a good indicator to determine if it's a tree to leave, to grow or not. And for them, usually it's a UGS, so it's a tree that you don't want to leave in the forest because it might, well, it has the potential to spread to other trees and the probability to kill others. And it's a probability that this one might be dead in 10 years. So for example, on the next slide, we have beech bark disease. Well, this one is fairly common, and you guys probably have seen it in the bush. It mostly affects the American beech, and it's present in Ontario and other provinces throughout Canada. And this disease is a result of a pathogen, but it's a result also of the scale insect that plays a big role in that. So in Larose Forest, we don't have pure stand of beech, but we're lucky enough, we are still observing the woolly stage. So the first picture on the left, you see the woolly envelope from the Nymph Stage. So it looks like snow on the bark right now. And that stage usually is in the fall. So the beech scale insect, it introduced itself around midsummer, and the female deposit her eggs in the bark fissures. So the larva hatch, and then it stays in the same place or migrate to other cracks. And in the fall, the nymph becomes stationary, and again, it secretes the woolly envelope. So this woolly envelope makes the tree look like it's covered in snow, and the scale insect overwinters in the bark of that tree. The fungal spores are decimated by rain or by wind, and it penetrates into the tree through wounds, and it created the scale, like the picture you see on the right. So that in the middle, we have the orange fruiting body from the fungus, but the canker blisters are on the right, and those ones you might also see. So it's multiple stages before you see your tree severely affected. So it might take 2 to 10 years for your tree to die before it gets, it takes 2 to 10 years for it to die. It's okay. We have another one here, the Horseshoe Kong, typically on poplar, but also on other hardwoods. But those trees are not as conks. Well, those conks are not very. How can I say that? It indicates that the tree is a UGS and there's rot in the middle, but we usually keep it for wildlife. So it's a major defect on poplar, and you know that this means that it might break in two, and typically poplar doesn't grow for 100 years, 80 years, and they're maxed out. So when you're tree marking, you want to leave a tree with those canker on it, so that it'll create wildlife habitat, like cavity trees, like on this picture here. We could see that's a nice cavity that the woodpecker had made, and it's a nice roosting cavity. Nectria disease also. Whoops. Next slide, sorry. We also have in hardwood Nectria target canker and Utapilla, which is the Cobra Canker. Those diseases are characterized by an area of dead bark surrounded by a ridge of callus tissue. The first one, the target canker, you could see the lines through it. Right here, it looks like a target. And the cobra, well, you can see the head of the cobra shape, especially if you come from the side of it, you see that it's a different shape. Those cankers will kill trees, and so it's a decay that's really important that will eventually, with the wind, break at that point. So especially in the hardwoods, in the maples, we see them a lot. Next. Here we have the clinker fungus, another one. It's called the chaga, also typically on the yellow birch. And what, as a tree marker, when we see it, usually we would mark it, because inside, if we see the fruiting body, that means that inside it's all rot. This picture shows it like on the right. You see the damage inside, and just the presence of a single conch will indicate extensive hardwood decay. But to keep biodiversity concerns, if I see a yellow birch in a conifer stand, I would usually keep it as a diversity tree, and also for other species. Yeah, looking for my words here. So choosing the right tree in conifers, assessing every tree, you want to see the potential for growth. So if you end up seeing red ring rot or white pine blister rust or velvet top fungus, tomentosis, or foamies on your tree, that's where you make the decision, is this a good tree to keep or not? So next slide.
I clicked it.
It's coming.
There we go.
So this one is the red ring rot. it's rarely that obvious. Usually it's smaller than that. The perennial conch found underneath the dead branch, that's what you usually see. And it's for the most part close to the ground. So it's easy to see it, and it's easy to miss also. But the infected trees suffer a loss of merchantable volume in it, and it's structurally weakened because it's full of rot, and it might extend also like a column to 10 meters above that conch. And it's also common on wet sites or shallow soils. And in older trees also, you would typically see them. And when we're tree marking, we might be retaining them for maintenance of the stand stalking target, so the crown closure. If we're missing trees, well, this one is one we would like also to keep, just to maintain the stalking. Here in Conifer, we have also the white pine blister rust. Easy to identify when on the first picture. Like this one is on a way out, and it's easy to identify, but when it's just starting and you see only the not as advanced stage, well, this one has resin flow on the bark in the canopy, and this one's easy to miss when they're mature. On the right picture, you have on the region white pine. Here you could see these yellow reddish brown spots, which is the fruiting body of that fungus. And this fungus needs also an alternate host. It needs ribes to complete the infection cycle. So it's typical for us when there is an opening in the plantation, well, ribes are established first in there. So white pine blister rust is fairly common in Larose. And it can travel many kilometers also. The spores, I mean, for that fungus travels a lot. And yeah, it's easy to see when it's fairly dead, like this one on the picture. Next. So here we have the shoestring rot or Armalleria. It affects most of our hardwoods and our conifers. And to identify it in conifer, you would see the premature yellowing and underside the foliage, and you would see some dieback in the crowns, and it's also the crown depth from the top. The crown is dying from the top. In red pine, we see the needling are really short, and it shows that the tree is affected by something, but it's not as obvious. You would have to dig and see the rhizomes, like on the picture, you see the black rhizomes. That's a really advanced Armalleria affected trees. So in the hardwood, you would also see the bark peeling or decaying wood in the root collar area. Steve will be talking more about the mycelium and the cambium, that you could see that's affected. And it has also a wide impact on the forest. To you, Steve.
Thanks, Manon. So there are several fungi that can cause widespread decline and mortality, but usually they only kill individuals or small groups. When the trees themselves are on a good site and they're healthy and vigorous, where these fungi become a significant problem is where the trees are growing on a site that they're not well suited. And when you add unfavorable weather conditions that reduce vigor, like drought and flooding and periods of extreme heat, on top of the poor site conditions, you have a recipe for these root disease fungi to really thrive. One of the things that really helps out is if you have a plantation and you do regular thinning, that can really reduce the risk of root diseases, because it really helps the trees to maintain vigor. But when they're growing on a site that they're not well adapted to, eventually they're going to hit a wall when they reach the capacity of the site. And these root diseases really become a problem when that happens. So in some cases, though, like for example, in the Larose Forest, the forest itself used to be managed by the Ministry of Natural Resources up until about the early 90s. And then there was a period of about 5 to 10 years where the forest was kind of in limbo and really there wasn't a whole lot happening. And then there was another period of about 5 years or so before things really started to take off again. So there was a period of about 20 to 25 years where there wasn't a whole lot of thinning going on. And the typical schedule for thinning to maintain vigor and health in a plantation is about every 10 to 15 years. So a lot of the plantations in the Larose Forest were overdue for thinning to keep them on a schedule of very good health and vigor. So root diseases have really become a problem in the Larose Forest, especially in our red pine and our white spruce. So in a lot of cases, the white spruce have never been thinned. So we're looking at plantations that are 50, 60, 70 years old that have never had a thinning. And then with the red pine, they were thinned regularly, but with that 25-year period before they were being thinned again, they've had an opportunity to lose vigor. And a lot of these species, they were planted on sites that they're really not well adapted to. White spruce doesn't deal well with wet sands, and that's primarily where they were planted. And red pine really doesn't like wet feed either. So when it's on a site where the water table is closer to the surface, they can lose vigor and become susceptible to these root diseases. Another wild card in this whole mix is climate change. We're seeing a lot more frequent drought and a lot more frequent extreme weather events, which we don't really know where we're going in the future. So the being able to predict the impacts of climate change is very difficult. And all I can see is that these root diseases are going to become even more of a problem as climate change takes effect. So to be able to identify heterobasidian root disease, the best and easiest way is to find the fruiting bodies. So they develop typically in the fall, and they're kind of popcorn-like shaped. And sometimes it's easy to see when you have a tree that's heavily infected, like this one here. And these are fairly newly developed fruiting bodies. So they're nice and bright white, so they really stand out. But they're a pretty persistent mushrooms, so they can persist through the winter and into the next season. And this is a fungus that's a little bit further along the fruiting body, sorry. And this is a lot more common to what we find when we find heterobasidian root disease. I'm just going to refer to it as HRD just because it's easier to say. But most often, it's difficult to find it. As you can see, this is my index finger in this picture. So that's how small the fruiting body is, and that was the only one that was on this tree. And above ground, this tree looked healthy, but it was the disease was present nearby, so we kind of knew to be looking for it. And then in some cases, you need to get down on your hands and knees and dig out of the root system and take samples and send them away to confirm that is what you're dealing with. This root disease, it's not native. It was introduced from Europe, and likely it was on nursery stock, but it's a huge problem in Europe. And the photo on the right there is he's a forest pathologist from the University of Wisconsin, and he was doing some research in Larose Forest, and he was explaining that the HRD is a huge problem in the Lake States, where it's causing widespread decline in mortality. We're not seeing that kind of mortality in Larose typically dealing with this disease. Usually it's related to sort of expanding group mortality, and I'll talk about that a little bit more in a minute. So this disease was identified in Larose Forest initially about 60 plus years ago, and there's been a lot of effort over the years to try and control this fungus, including stumping, trenching, burning, the use of borate salts. That was done for quite a while, until it was restricted in Canada. And more recently, there's the use of a product called Rot Stop, which is a biocontrol. So it's quite effective in preventing the fungus from becoming established. Where the jury's still out is how effective it is in preventing spread once it's already infected a site. So this is kind of typical of what you would see for the decline in mortality related to HRD. So in the middle of the expanding pocket, you can see trees that have been dead for a while. And then out to the side here, you can see trees that are more recently dead. They still have their fine branching. And then over here, you can see some pretty severe decline. And then around the edge of that pocket of dead trees, the trees out there, you can see that they sort of have decline on one side. The crown is a little thin. And then outside of that, things are looking pretty rosy. The problem is you get one tree that's infected with this root disease, and all the root grafting that goes on in plantation, one tree is connected to the 16 around it. So you add one tree to the next tree, which has another 16 trees connected to it, and then the next tree, which has another 16 trees connected to it. It just goes exponentially from there. So this rate of spread potential for this root disease is pretty scary. But like I mentioned, what we've been seeing in Larose Forest, we're seeing these pockets of decline, and I'll talk a little bit more about how we're trying to manage these things. But it tends to be isolated pockets of mortality like this. This is very characteristic of HRD. Armalleria root rot, however, is a much bigger concern for us. It can cause the pocket mortality like HRD, but we're seeing in Larose a much more widespread decline, especially in red pine, spruce, and tamarack. It is a native fungus, which is always present in the soil. It does spread by spores and by root, but primarily by root contact, similar to HRD. Like I said earlier, with red pine, the 16 trees around one that's infected are also affected. Decline in mortality can be very fast, especially if stresses like nutrient deficiency or drought accumulate. So if you get repeated years of drought, or a drought year followed by a very wet year, followed by another drought year, followed by another very wet year, like those kind of things really have an impact on the vigor of the trees, and they have a hard time keeping this fungus at bay. Decline in the fruiting bodies are sort of a light yellowish brown color, and there's a whole bunch of different varieties of Armalleria that are out there, but the one that concerns us the most is Armalleria ostoya. It's quite virulent, and it can have a big impact on your forest, and that's the one that we're encountering. Some of the other signs of Armalleria root rot are these white mycelial fans between the bark and the wood, so in the cambium layer. So This is a strip of bark that was peeled off of a recently dead tree, and you can see the extent of the fungus here. Like these are the white mycelial fans that I'm referring to, and they're sort of yellowy white, spongy, and they have a really decadent mushroom smell to it. Like it's quite it's a pleasant smell. It's not it doesn't smell like rotting wood per se. It just smells like nice fresh mushroom. And then, as Manon mentioned earlier, the rhizomorphs, the black rhizomorphs, are another characteristic of Armalleria. The unfortunate thing with the rhizomorphs and the mycelial fans, at least above ground, anyways, is that they don't really show up until decay is advanced or once the trees have died. And the fruiting bodies, they're quite short-lived. They're only out for like a matter of a week or two, maybe, in the fall. So unless you happen to be there at the right time, it's hard to find these things. So since those fruiting bodies are such short-lived, and because the mycelia fans above ground are typically not present until the disease is very advanced, the best way to confirm is to dig up some roots of some declining trees to see if you can find the mycelial fans on the main roots. So you can see an example here. There's a small wound on the root, and that's where the mycelial fan has decided to develop. But when you start digging away from the tree along main roots, you'll often find a lot of this stuff on the root systems of trees that appear to be fairly healthy. So it's something that we try to look for to determine what fungi is out there and what's causing decline. Another method that we use to try and identify whether or not Armalleria root rot is causing problems is to look for overturned trees and look for signs of rot in the root system. Like this here is typical of Armalleria root rot. It kind of has a stringy texture. It's sort of a yellowy orange color. It's quite spongy, and it often retains a lot of water. This is typical kind of rot that associated with Armalleria root rot. Over the years, we've sent many samples to the Ministry of Natural Resources and Forestry and their labs to be able to confirm some of the root decay fungi that we're dealing with. Just wait for my slide there. Okay. So some of the symptoms of decline due to Armalleria, they're similar to HRD. So you have the thin crowns, yellowing of needles, premature needle drop. And you can see this in this photo here. They've basically only got the current year's worth of needles on each branch, compared to this tree here, which has several years of needle growth on it. So this one is probably in much better shape than the rest of these. However, in our experience, Armalleria tends to be more uniform decline than an expanding pocket like HRD would be. So this type of decline can be quite widespread. Because Armalleria spreads very rapidly from one tree to another and through the root systems, sometimes the only thing that can sort of prevent the root rot or sort of contain the root rot from spreading are things that sever the root connections. So roads and ditches, a change to a different forest type, or a significant change in site quality. So for example, say you have a lower lying area and the topography changes and you have a significant increase in the depth to the water table. That will have an impact on the spread of Armalleria. Tomentosis root rot. This is another native fungus that primarily affects spruce, but it can also affect white red and jack pine, balsam fir, hemlock, and larch. It does spread by spores, but it also spreads by root contact. You're probably noticing a trend with these root diseases. They can spread quite readily by root contact. So plantations are especially susceptible to these root diseases because there's often more grafting going on in a plantation than there is in a natural forest. So the fruiting bodies are dark brown with a yellowish brown margin. And they often appear at the base of stumps or in lines along the root system. So it's not uncommon to be walking through the woods and see these straight lines of mushrooms. That's a pretty good indication that the surrounding trees are being affected by this fungus. There's another fungus that looks very similar to tomentosis. It's called velvet top fungus. I'm not going to try and say the Latin name for it, but it's quite similar, but the mushroom is quite a bit bigger. And the rot associated with each of these is quite different. The Tomentosis Rot is like this photo here. So the wood ends up being a yellowy orange kind of color. Advanced stages of the rot in the stem are sort of reddish color. And it's what's referred to as a white pocket rot. So you can see these little white pockets within here. So that's typical of tomentosis, where velvet top, the rot, it's a brown cubicle rotter. And so you end up with this blocky brown type rot, and it can result in some pretty severe heart rot. And those trees typically they end up breaking off above ground, where tomentosis will rot away the root system and the trees are susceptible to wind throw. It's not uncommon for us to find tomentosis, velvet top, and armalleria all on the same tree with spruce. So there's spruce has a hard time at Larose. Here, sorry about that. Bit of lag on my end here. So site conditions are probably the best indicator of where root diseases can become a major problem. Soil depth or soil type, depth of modeling, soil pH are good indicators of whether or not a site is capable of supporting a certain tree species for the long term. For example, red pine on a site with less than 50 centimeters to a calcareous soil layer, or white spruce growing on wet sands. The trees will grow well for a while until they reach the limitations of that site, and then they'll start to lose vigor, and they become susceptible to these root rotting fungi. The photo on the left is a fine sand where modeling is about 25 centimeters from the organic layer. This is a site where root disease killed approximately 4 hectares of 57-year-old white spruce plantation. And the photo on the right it shows the stunted root system of a red pine that was growing on a site where there was approximately 35 centimeters to modeling, and there was also evidence of calcareous soil at that range. This site in particular resulted in the death of about 2 hectares of 64-year-old red pine, and this was confirmed to be the mortality was caused by Armalleria root rot. So what I'm referring to is a stunted root system. These roots aren't broken. They're short and stout, and then you have the fine roots. So right here is where the tree hit the restrictive layer in the soil. So the trees grew fine until they got to that point, and then the fluctuating water table and the calcareous soil layers prevented the root system from expanding into that, and the trees lost vigor, and then they succumbed to that root disease. So one of the things that we've done is we're trying to assess the risk of where we're going to encounter these root diseases. And most of what we're looking at is site. So we've done an evaluation of risk. The photo that I've got up here, this map is related to red pine plantations. So we've assessed risk based on the soil depth. Almost all of our sites are very fine sands, so the soil texture doesn't vary a whole lot, but the soil depth does. So the depth to those restrictive layers that are going to reduce vigor, these are things that we can map using our aerial photography and our digital elevation model and our independent knowledge of the site. So in this example here, the red are red pine plantations that are either currently experience significant decline, or we expect significant decline in the next 20 years based on the site conditions. The orange are where there are some signs of decline, or we expect that there's going to be decline in mortality in the next 40 years. And the yellow are sites where there's minimal evidence of decline, and we don't expect that there's going to be significant decline or mortality for more than 40 years. So this allows us to prioritize our actions of where we're going to go and what we're going to do when we get there. Some of the things that we do beyond that is we receive aerial photography every 5 years. And this is one of the tools that we use to monitor areas to make sure that we're seeing, because we can't be everywhere at once. So this is a quick way for us to be able to evaluate and see if there's sites that are being affected by root diseases. In the example here, you can see within a 5-year period, trees that looked apparently healthy have since died. So this to me looks like an expanding pocket decline type of mortality. So I would expect to find some HRD on this site, but this will trigger a response from us to go out to this site and take a look around and see what's going on. In this example here, evidence would suggest that there's probably some more widespread decline. You can see these trees here, these are all red pine, right? So these trees here are showing that they're significantly thinner and less healthy looking than the trees around them, and in here as well. And you can also see individual trees that have died within here. So this would be an example of a site that we would suspect is probably being affected by Armalleria root rot. And again, we will have to go on site and do some extra investigation to see what's going on and to confirm or deny whether or not it's Armalleria root rot or if it's being caused by some other factor. So when we're dealing with root diseases, our management prioritizes on those high and moderate risk sites so that we can activate a progressive conversion to other species before the site is overrun by the diseases, if we can, and before we incur significant losses to mortality from these diseases. This includes actions to develop healthy understory under the with species that are less susceptible. With species that are less susceptible to these diseases. So, for example, in this case here, there's a nice healthy understory of red maple and yellow birch growing under a mix of red and white pine. So this might be a situation where we would encourage that hardwood to develop in the understory, and then over time through progressive removal, take the overstory and replace it with that hardwood understory. On the right, you have healthy white pine coming up under a red pine plantation. So this is a situation where we might consider promoting that white pine, doing a progressive removal of the overstory to nurse it along and help it grow. And eventually the white pine would replace the red pine on that site. So that's the ideal situation. Unfortunately, that's not always possible. but what we're doing right now to try and encourage the development of a healthy understory, there's a bunch of things that we're doing. Generally here, in this example, we have expanding pocket decline. This site in particular, it was related to HRD. So the decline in mortality seemed to have been limited to those pockets. So we did regular thinning throughout the majority of the plantation. And then we did salvage in the declining pockets, which is outlined in red. And the blue is what we expect the pocket to decline by the next harvest entry. So in the next harvest, we would likely be salvaging what's described by the blue ring, but still doing regular thinning in between. And the idea behind that is that the salvage is that we're capturing any decline in mortality that would happen in between our entries. So as I mentioned earlier, in red pine, the typical re-entry is somewhere in the 10 to 12 year range. So we would salvage what we would expect to lose in that time frame. Another method that we're using is called variable density thinning. So this is another method that we're using to promote a progressive conversion to other species. So we use this, and typically what happens here is you would do some regular thinning in the bulk of the plantation. These blue areas are areas where we did a little bit heavier removal than what would be done in a normal thinning. And the idea being there is that there's already regeneration established underneath. So we're trying to release that, or we're trying to create a situation where good regeneration can get established. And in those areas also, these are areas where we're seeing some level of decline, but it doesn't look like it's going to be something that's going to cause significant mortality before we return to do the next thinning. And then these red outlined areas are areas where we did salvage of a pocket decline. So in instances where we have widespread decline, and as I mentioned earlier with Armalleria root rot in particular, the decline in mortality can happen very quickly. So often we don't have time, well, I say often, sometimes we don't have time to perform a progressive conversion to another species. In these situations, a salvage at a larger scale might be implemented to avoid significant losses. These photos here, they show an area where decline was widespread and it was fairly uniform throughout the patch. Multiple samples were taken and sent to M&R to confirm that it was Armalleria root rot that was causing the decline. In this case, we had to use roads, which are indicated here, roads and trails, which sever those root connections. And then here is a ditch system that also severed the root connections. So we had to use those as a barrier to the root fungus. I'm using my hands like you can see me move my hands around, but anyways, Manon's enjoying it. So these roads and these ditches, they indicate a break in the root connection. So we were able to use that as the boundary for our salvage. And you can see that this is more than 5 years later. This is 8 or 9 years later, I think. You can see that there's very little evidence of decline except over here. So that I think we chose the right spot to put the boundaries for the salvage. Sorry, I'm just waiting for things to load here. These photos were taken from a salvage operation that we did last winter. So this site unfortunately had a whole bunch of things that were going wrong for red pine. There were multiple years of bad drainage. Ditches had been blocked. There were swamps that were expanding. This site is generally low and wet. We found HRD, we found Armalleria root rot. We found restrictions to the root development, like there's a calcareous layer in there that was preventing the red pine roots from extending beyond where they were. So unfortunately, we had to do significant salvage here. This is the largest salvage that we've ever done and hopefully ever will do. It amounted to approximately 15 hectares. And unfortunately, there weren't significant breaks. Like in the previous example, there weren't really any roads that were preventing the spread or ditches and that kind of thing that were really preventing the spread. So unfortunately, we had to trigger the salvage response here. And these photos just sort of show the results of that. So you can see in this photo here, you've got standing dead red pine surrounded by pretty decent red maple. And in the background, it's hard to tell in this photo, but I believe that's an area that where there was a significant topography change. So it would be higher ground, so better site for red pine. So we were able to do a regular thinning in that spot. And the photo on the right, you can see that there's some white pine regeneration in the background here. And then here is where the stand condition changed to a white pine dominated forest, which wasn't being affected in the same way as the red pine. So the management strategies that we've implemented in Larose Forest, these have been a work in progress for over 13 years since I've been in the region. I was first exposed to decline related to root diseases in my past life as a forest senior compliance technician on Crown Lands in Renfrew County, where they were seeing much worse than what we see at Larose Forest. And just wanted to send a thank you out to all the folks that have helped us over the years in developing the management strategies that we're implementing in Larose today. So we've learned a lot over the years, but we're not done yet. There's still more to learn, and we're continuously learning. I did want to say a special thank you to Doctors Richard Wilson and John McLaughlin, who really helped us out in the earlier period to be able to identify these root rotting fungi, and with providing us with some guidance in the development of our management strategies. And also the other forest managers throughout Ontario that are dealing with similar issues. They've done a lot to really help us out to develop these strategies in the rows. So unless Manon has more she wants to say about things, that's all I had for now. And if there's any questions or comments, feel free.
Thank you very much.
Pass it on to Lynn. Let's see.
Oh, that was really excellent. Thank you very much. Love all the pictures. I think I have a few questions, but I'll open this up to other people. If anybody else has a question, let's see if we can just do this one at a time. Go ahead, Jonathan.
Two questions. So one is something that I've always wondered, but most of those plantations are just like one species. Why is that so? Why don't those plantations have multiple species? Do you know? They're mostly monoculture of red pine or something like that?
There's a variety of different plantations in Larose. The biggest number of plantations are primarily red pine, white pine, and white spruce. And the main reason why in the past plantations were established in single species is it's much, much easier. So uniformity breeds simplicity. So it made things a lot easier. But I will say that all the tree planting that we do now, they might be dominated by a single species, but we try to incorporate other species in there to add some diversity in our plantations. And most of the planting that we're doing is underplanting. So it may not be the same species as what's originally there. So the bulk of our planting is white pine dominated, but we also plant red oak, bur oak, white oak, hemlock, red spruce. We've planted yellow birch, sugar maple, black cherry, black walnut. So we're doing our best to try and introduce additional diversity through tree planting.
I can wish you good luck for that. And other question is real quick, but it's you might even not know the answer, but it's worth to ask. But there's a spot I want to explore near Windover, and I don't know if it's private property or not. Do you know if there's anyone I can ask to get those information so I won't be trespassing? Or I know it's a bit unrelated. I'll take the chance.
I think around Wendover, most of it's private lands.
Yeah.
But I mean, we could definitely tell you whether it's our property or not. And then South Nation Conservation also owns properties in our region, and there is some crown land also. But I think the bulk of the properties around Wendover are probably private. But we do have a property out there.
Yeah, we could send you a map by email. Lynn could share our info. And if anybody has other questions also throughout the year or so, they could always give us a quick email, and we'll be gladly answering to that.
Sure, yeah, I'd like that. Thank you. Very good.
Maybe you could send me the coordinates, Jonathan. Anybody else?
Yeah, I have a question.
ahead,
If I
Tanya.
may, are you trying to grow trees to sell for lumber? Is that one of the objects of Larose Forest?
It is one, but it's not the sole. As I mentioned early in the presentation, it is the production of forest products is one of the things that we're doing. But the idea is that we have a balance of the economic as well as the environmental and the social and the cultural features that the forest can provide. So we have a significant focus on recreation, so outdoor recreation. We do a lot to promote wildlife habitat, and we do a lot to preserve water quality and quantity as well. These are just some examples, but the primary goal is not necessarily to produce forest products. It's one of many.
What do you do with the salvaged wood?
The salvaged wood, everything, all the wood that we harvest goes through tendered sale. So we don't actually physically do the cutting. We put it out to a tendered sale, and we have contractors come in and do the harvesting for us under a contract with us.
Even when you have fungi and you could spread somewhere else?
Most of these are most of these root rotting fungus aren't spread by moving the logs around. Typically it's through spores and through root connection in the ground. Armalleria root rot, for example, it's everywhere. So us moving infected wood around isn't going to spread it because it's already there. Things like Heterogeneous, that might be a different story, but typically it's widespread throughout North America and Europe. So it's already beyond the ability to quarantine it. I guess that's the best way I can explain it anyhow.
Has the presence of the Armalleria or Heterobasidian in the salvage stand, has the presence of it decreased the value of the wood that you salvage from the stand?
If we wait too long, it definitely can. That's part of the reason why we do a salvage when we do, is to try and recuperate the value that's been invested before we lose a significant amount of it. So if we were to wait for the trees to die, by then it would be too late. It would be worth nothing. But if we can get to it before there's significant rot in the trees, then we're still recovering the value that's in those trees.
I have another question. I read somewhere that earthworms are not good to have in forests. Is that true, and why would that be?
It depends on the type. There are a bunch of non-native earthworms that have been introduced into hardwood forests, and they have a significant impact on the nutrient balance. So I'm by no means an expert on that one, but that's my knowledge of it, is that it has a big impact on the chemical makeup of the soil and the nutrient availability and that kind of thing.
You do plant a numerous type of trees. Do you plant sometimes fruity shrubs like the elderberries and serviceberries and all those?
We've done that on one site through South Nation. We did a riparian habitat enhancement project, and there were some shrubs involved in the planting at that point. But typically we're not in the habit of planting shrubs. But part of that project with South Nation Conservation was to develop a pilot project of sorts to determine whether we could do that kind of thing on other sites. So part of what we did on that site was there was a ditch system that was naturalized. So the ditch was, instead of it being a straight line, they put in a variation in the stream to reestablish the natural progression of the stream. And part of it was the planting in the riparian area. So like we're using that as sort of a test to see whether that was something that we could apply in other areas. So I mean, it's not out of the question that we could get into doing stuff like that in the future.
Good.
Why do root diseases spread more quickly in plantations than in other forests?
Part of the reason is the concentration of single species. The other reason is plantations tend to be higher stocking than natural forest. So there's more trees in a smaller area, and you get more extensive root grafting. When you have a single species and lots of stems, you would get more root grafting, so there's more connection. So the root diseases tend to spread more readily in a plantation. And in some cases, the plantations, the goal of the landowner at the time was to put a certain species on the site, regardless of whether or not the site was well adapted for those trees. So for example, if you really wanted red pine and you planted it on a wet site, you would be more susceptible to root diseases because it's not well adapted to that kind of a site. So what we're encountering in Larose Forest is that some of the plantations were established on sites where those trees didn't really belong. So that's where we're ending up with issues with root diseases. What's going on under the ground is way more complicated than what we see above ground. So some of the interrelationships that are happening underground. You look at Larose Forest, for example, which is a heavily disturbed landscape. After Europeans came and cleared all the forest and then tried to farm it, and there were fires and wind blew all the topsoil away. Lord knows what happened to the chemical makeup of the soil and those mycorrhizal fungi that I was talking about earlier. What happened to those things when all the trees were removed and fires and agriculture and wind and all this stuff impacted the site? So that could play a factor also in the susceptibility of these trees. So even though they may have been here before, this species may have been here before settlement, with all these factors that have altered the site, maybe they don't belong here anymore. Maybe something else is better suited.
Yeah, I meant to ask you, what is root grafting? You mentioned that several times.
Root grafting is basically where two trees have a separate root system, but where their roots overlap, often they will fuse to each other.
Okay.
So those two trees are connected. So like I was talking about earlier, like the root grafting in red pine in a plantation is quite extensive. You can have one tree that's connected to 16 around it through their root system.
Mm-hmm.
So that's what I'm referring to by root grafting.
Okay, thanks.
No problem.
In my walks or skiing in the Larose Forest, I noticed on some of the trees they have letters. What is the significance of the letters? W and there are others.
You want to take that one, Manon?
Yes. Okay, so Diane, when we mark trees to identify them for the harvester, usually when they're marked in orange, they're trees to cut, and marked in blue are trees to leave. So these ones are usually wildlife trees. So we mark W on it, or if it's a cavity tree with a good cavity in it, sometime I would write C on it, but the color means more importance for the harvest operator. And you might see also numbers on them. Yeah. Typically in red pine plantation, those are for hydro poles. So the number are the actual length of the pole that's being harvested. So you might see a 37 or 42 or something like that. That's the feet.
Okay, that's great. Thank you.
There's more too.
Yeah, go ahead.
We have an arrangement with the Ministry of Natural Resources. So there's permanent sample plots established in our forest also for the growth and yield program. So you might see numbers and letters on trees related to that. And when you see the blue M or the blue W or the blue C, that's more, we put that on the trees for auditing purposes. We get audited regularly by auditors representing the Forest Stewardship Council. So our forest certification mechanism. So we're regularly audited through that process. So part of the reason why we put those letters on the trees is to indicate to the auditors that that's the reason why that tree was kept. So that's it. We have a whole bunch of targets related to cavity trees and mass producing trees. So the trees that produce nuts and fruits for wildlife. Also, like Manon mentioned, the cavity trees, we have targets for those as well. Solitary hardwoods and conifer stands, solitary conifers in hardwood stands. There's all sorts of things that we're indicating when we're tree marking. And most of the letters and numbers that you see are for auditing purposes.
You do plant trees and shrubs, and do you sometime plant flowers, wildlife flowers?
We haven't gotten into that a whole lot. I don't know.
No, the only thing I could think of is when the mowing is happening, we are trying to promote areas where we've put some seeds in with the Asclepiad the
Milkweeds.
milkweed. Thank you, Diane. So we've tried the milkweed, and it didn't work as much as we thought. But no, typically flowers, we didn't get into that.
If we do seeding, say we're doing seeding for stabilization or something like that, we'll get a native seed mix, but we're not actively targeting specific wildflowers and that kind of thing in the seeding. It's more of we need vegetative growth, and we'll make sure that we're using a native seed mix rather than something that's not native.
Yes, of course. Thank you.
But
In relation,
go ahead.
oh, in relation to your comment about how complicated things are below the ground, just out of curiosity, if you've read the number of books lately, like Entangled Life, about fungi, and if you have, I'm curious about your comments.
I haven't read it yet, no. I'm definitely taking a more vested interest in it, but I haven't dug into that one yet.
Definitely worth reading, by the way. Fantastic book. But I also have a question. Do you take into account bird life and supporting bird life in any way?
Absolutely.
Yes.
Manon, you want to take that one too?
Yes, we do. Can you repeat the actual title of that book?
Oh, Entangled, what is it? Gosh, I don't have.
Entangled Life by Sheldon Mandrake, I think his last name is.
A brilliant young man,
He's
just amazing.
been studying fungi for quite a while. His father's a scientist in a different area.
Okay,
But it's
thank
sort of a
you. That's-
continuation of these numbers of books that are out on the incredible things that happen with fungi under the earth.
So for birds, typically we do in an inventory throughout all of our operations. I'm an enthusiast of ornithology. I've been for many years interested in birds, and what I'm doing usually when I'm doing inventory prior to harvest, I check out for typical habitat that are sensitive, and I go out and do some birding throughout that season. And also I do the marsh monitoring program, and I go out closer to marshes to identify any species at risk. I'm also on the eBird list that I keep as precious in my phone. And every time we do encounter, when we're tree marking, if we encounter special habitat or stick nest, we have to fill out a form, and it's a good form for us to keep, so we could protect any nesting bird that we see in that habitat. We've modified prescription in the past with those field notes. Steve and I are always, almost every day outside, and we try to at least protect as much habitat we can for in nesting birds and all other migratory birds.
Do you ever report any of your bird sightings on Bird's Digest? Because that eBird is great for big picture, but it's, yeah, you know what I mean?
No, I've never used the Bird Digest.
I will send it to you.
Okay, thank you.
Okay.
Thank you. I'll be glad to share.
Wonderful.
So like Manon mentioned, we're constantly on the lookout for habitat, not just for birds, for all wildlife species, and we do make modifications to the way we manage the forest based on what kind of wildlife or other natural heritage features might be there. Typically the modification will either be to maintain or enhance that habitat. And it may include things like timing restrictions. So for example, for forest nesting birds, we'll avoid harvesting during the nesting period so that the birds can have their young and raise them before we go in there and make noise and harvest trees and that kind of thing. So to avoid destroying nests and hurting the birds and their young, we avoid harvesting during that time period. There's a bunch of things that we've got on the go related to wildlife habitat, and birds are included.
Yeah, so I do have a follow-up question. What about ATVs and snowmobiles? Because they sure make a noise and mess up habitat as well, or can. Is there any way you can move them to places that are less sensitive if they haven't done so already?
They're required in Larose Forest. They're required to stay on the designated trail. If not, they're subject to a fine. So that's the method that we have to manage ATVs and snow machines in the forest. So they have a designated trail network, and they're required to stay on those trails.
Thank you.
Are you harvesting any of the hardwood stands? And if so, does your observation of fruiting bodies of fungi affect your tree marking?
Yes, it does. We don't have a whole lot of there's not a very strong market for hardwoods around our area, especially the type of hardwood that we have. As time goes on, that may change, but typically when we do harvesting in a hardwood stand, we're trying to emulate those single tree or small groups of trees type of natural disturbance. And the forest fungi are the primary things that we're searching for, the tree killing fungi. So some of the examples that Manon referred to earlier, those are the things that we're really trying to target, partly because they cause decline and they cause mortality and they can spread within the forest. So we're using that to decide which trees are going to be cut during a harvest operation in a hardwood stand.
Does that mean that an infected tree is more likely to be cut?
Yes.
Okay, thank you.
Our goal in hardwood management is to promote the health and vigor, right? So we want to keep the trees that are doing very well and they're showing signs of health. So if we're seeing trees that have fruiting bodies on them, that's an indication of some pretty severe heart rot and issues that can spread to other trees. So those are the types of things that we're focusing on with our harvest. And it kind of feeds back to it's what's referred to as compensatory mortality. So you're removing trees that would likely die anyways through this process. That's the way we approach it.
Okay, thank you. It's almost 3:30 now. Is there maybe one more question?
Make it an easy one.
Okay, I have an easy one.
Okay, then let's wrap it up.
Do you leave a lot of dead bushes and things around so that animals have places, birds and other animals have places to hide, feed, that kind of thing? Or do you just clean up the forest and make it look all neat and tidy, which is the worst thing you can do for wildlife?
No, forests are not neat and tidy places. One of our targets is the retention of cavity trees, and ultimately those trees will become dead standing trees. According to the Health and Safety Act, we are required to remove to drop dead trees, but depending on the type of equipment, they can leave some. So we try to leave some dead standing trees. We try to leave some trees that are declining and will become dead standing trees. We also leave trees that have already fallen. Those end up getting left. And also there's parts of trees that get left in the forest that are left over from the tree that we're harvesting. So typically the top, or if there's a severe form issue, that'll end up getting cut out of the tree and left in the forest. So the goal there is that you're leaving woody debris in the forest in different stages of decay and different sizes. Generally bigger stuff is better. So we're leaving big down woody debris. We're leaving standing woody debris. There's all sorts of stuff that's left after harvest.
And if I could add, for the dead standing trees, for the most part, they're on the riparian zone. Just before you enter the marsh or you enter the wet areas, we have some dead standing. I've been monitoring an area where I've seen herons for the past years, but the dead standing are right before the plantation, and that's areas where we wouldn't even go and harvest. So these are taken in consideration, but we would never go as close to those dead standing. So we're actually, it's in Larose, we are lucky because it's pretty rich in wet areas. So yeah, we typically see them in those.
Well, thank you for your presentation.
That was really interesting, Manon, the idea of coming across some herons near a wetland. That was a wonderful presentation. And I've had several people have commented in the chat about, I'm sorry, my phone is ringing. Several people have commented, thank you. That was great. It was fascinating. Thank you for sharing your knowledge. And I forgot to add that the people in the club, lots of us really love the forest, and we're quite eager or willing to share somehow to help however we can with natural history in the forest. So we like this connection. Thank you very much.
Yeah, absolutely. Anytime you have anything you want to share about what you've found and where you've seen it, that all feeds into our decision-making process. Like I mentioned earlier, we can't be everywhere all at once. So any information we can get from folks like you is going to help us inform and make better forest management decisions. And I'm more than happy to have you guys report on what you're seeing. And maybe if COVID ever ends, we can all go out for a walk in the woods.
For our next Bio Blitz.
Yes.
Yeah, that sounds
That'd be
fun.
great.